Hello, welcome to my channel. So today let's look at the Leetcode 326, power of 3. Given an integer n, return true if it is a power of 3, otherwise return false. So example, if n is 27, then it's 3 cube, so it should return true. If n is 0, it should return false. If n is 9, is 3 square, it still return true. If n is 45, it's a multiple tree, but it's not a power tree, so we return false. So also, if it is a 1, then it should return true, because it's power 0 power of 3. So the constraint n is the entire integer range. So n actually it's also possible it's negative. And the follow-up, it asks, could you solve it without loop or recursion? So, so for this question, I'm going to give two solutions. The first one is using recursion, and the second one is the follow-up. So we will not use any loops or recursion. So let's look at the first one. So recursion. So recursion, we need to have a base case. So for this question, when n equal to 1, actually it is a base case. It need to return true, right? And if n is not a 1, but the n mod 3 is not a 0, then it definitely will return false, because n is not a multiple of 3, so it cannot be a power of 3. So then we actually can go to the recursion part. So the recursion, we can actually just return function n divided by 3. So for a number to be power of 3, for example, if 27 is a power of 3, is 27 power of 3, we can actually convert it to a problem is 27 divided by 3, which is 9, is 9 power of 3. So this two question actually is equivalent. That's why we can use the recursion this way. So let's start coding this. Also the time complexity. So the time complexity of this question is using recursion is log n, and using the space and time is both. Both O log n. Because we are actually every time we divide it by 3, so we can only divide it by 3 log n times. Also, because it's using recursion, it will need to use the stack. So the stack depth is a maximum log n. So okay, let's start coding the question. So if n is smaller than or equal to 0, we will need to return false. So now let's do the base case. If n is equal to 1, we can return true. And else, so if n is not equal to 1, but n mod 3 is not 0, then we return false. Then in the end of the function, we just do the is power of 3. Then we do n divided by 3, which should be integer, because n will be multiple of 3 if you go to this step. So now let's try. Okay, else if. Let's try those examples. If it's correct. Okay, it's correct. Okay, so it passed. So okay, this is the recursion. Now we can do the second with this without using recursion. So it's math. So what we need to do is we can find the maximum power of 3 in the integer range. Then we call it s. Then if then actually all the numbers we can, for all the numbers we can just check if the number is if we can have a mode as 0 if we divide s by n. So if it's 0, then actually we return true. If it's not 0, then we will return false. So how do we find the maximum power of 3? So we actually can start with the integer like the limit. We can call it limit, which is the integer dot max value, which is in Java it will give you the maximum possible integer. Then we use this integer to we firstly do a log on that integer, and then we do a round. Then we can do the power of 3 using that integer. Then we get the max power of 3. So let me code this, and then you will maybe have a better idea. So let's remove this. Okay. Yeah, so integer limit equal to, then I can do like x called actually I can use the math.log lim divided by math.log 3. So this one is actually it's like log 3. We do a log 3 on the limit. So then we need to round this. Actually, we can just do an integer. This will round down. Do a floor. Yeah. Then we got the x, so we can actually get s, as mentioned earlier. So math s is math dot we can do a power of x dot 3 then x. Then the rest is already, I just copy that. So if s is if n is a divisor of s, then we return true. Okay. Otherwise, return false. Math. Oh, okay, so it's a double, and then I need to convert it to integer. Oh, okay. Right, here we actually missed a case that n is actually we still need that condition. If we cannot have n, if n is smaller than or equal to 0, we actually can just directly return the false. So if n is 0, then make it this one illegal. So now it should okay. Yeah, also just mention the time complexity because this is math. So the time and space both O1 time complexity. So okay, let's okay. So it passed, and yeah. So this is today's video. So if you like the video, please subscribe or click like button. So thank you for watching. See you next time.